Hey guys, it's Miss Johnson, and I'm here to bring you the second part of our notes video series for 8.2. So we're spending a couple days on 8.2, mostly because it's a tricky concept. There's kind of a lot going on in it, and so we're going to take some extra time to talk about it. So I'm going to pick up on the front side of your notes page down at the bottom where it says find the LCM of the following polynomials. Okay, so in number 4, we have the polynomials p to the third plus 5p to the second plus 6p. And then our other polynomial is p to the second plus 6p plus 9. So the first thing that we have to do is factor, factor, factor. So I am going to look at this polynomial right here. This is like one of them. I know I can take a p out, and that leaves me with p squared plus 5p plus 6. And then I also know that that trinomial in the middle, I need a product of 6 and a sum of 5. That's 2 and 3. So I've got p plus 2, and then p plus 3. So these are like the three factors that make up this whole polynomial. Okay, so you've got this factor of p, this factor of p plus 2, and this factor of p plus 3. So now let's take a look at the one on the right. I have p to the second plus 6p plus 9. I don't have a GCF to take out in this one, but I can factor that. I want a product of 9 and a sum of 6. So I'm going to make that p plus 3 and p plus 3. So again, these are the two factors that make up that polynomial. Now, here's where we get into LCM. So the LCM is going to be each factor that you see, the most number of times you see it in each list. So I know I need a factor of p because I have a factor of p here on the left. I know I need a factor of p plus 2 because I have one on the left. I don't have any over here, but I still have one on the left. So I need that. Then the p plus 3. I have one p plus 3 in this list, but I have 2 in this list. And I'm going to need it the greatest number of times that it appears. So it appears once in this list, twice in that list. That means I need it twice. So that's my LCM. Let's take a look at number 5. In number 5, I have q to the second minus 4q plus 4. And then I also have q to the third minus 3q squared plus 2q. So those are my two separate polynomials. If it helps you, you can put parentheses around them so that you recognize that they're two separate things. That and in the middle is separating them. So first, factor, factor, factor. So I have q squared minus 4q plus 4. I need a product of 4, sum of negative 4. That's going to be q minus 2 and q minus 2. Then q to the third minus 3q squared plus 2q. I can take a q out from all of them. That leaves me with q squared minus 3q plus 2. And then I also need to factor what's left over. So q squared minus 3q plus 2. I want a product of 2, sum of negative 3. I still have that q that I pulled out front. I need negative 2 and negative 1. Q minus 2, q minus 1. Okay, so this is the list of factors for the one on the left. This is the list of factors for the one on the right. I have 2 factors over here, 3 factors over here. So the LCM is going to be, I know I need that factor of q because I have one over here on the right. Then when I look at q minus 2, I have 1 here, but I have 2 there. So the greatest number of times that I see it is 2. I don't need all 3 because neither polynomial has 3 of them, but I do need 2 because this one has 2. Then q minus 1, I have 1 here, none there, but that still means that I need 1 because the greatest number of times I see it is 1. And there's my LCM. Let's try number 6. Number 6 we have, let me grab it down here. I'll put both of these down. So I have x to the third minus x squared minus 2x. There we go. And I also have x to the second minus 4x plus 4. So factoring on the left, got to start with the factoring. I have an x in all 3. I can take that out. That leaves me with x squared minus x minus 2. Then I can factor what's left over in the middle. product of negative 2, sum of negative 1. So I have x out front. A product of negative 2 and a sum of negative 1 is going to be x minus 2 and x plus 1. So there's my factored form for the one on the left. Then on the right, I don't have a GCF to take out, but I can split this into two factors. I want a product of 4, sum of negative 4. That's x minus 2, x minus 2. So negative 2 times negative 2 gives me the positive 4, and negative 2 plus negative 2 gives me the negative 4 in the middle. So here's the three factors in the list on the left, and here's the two factors in the list from the one on the right. All right, so the LCM. LCM, I have a factor of x. Then I have x minus 2. I have 1 here and 2 there, so that's x minus 2 and x minus 2 because I need 2 of them. I only have 1 there, but I have 2 there, so I need 2 of them. Then I have that x plus 1. I also need that. So basically, you just need to make sure you have all your bases covered. Could I divide this LCM by that one? Yes, I could, because I have the two factors of x minus 2. Could I divide the LCM by this one? Yes, I could, because I have a factor of x, I have an x minus 2, and I have an x plus 1. That's the least common multiple, and there it is. All right, one more of this type, and then we'll be done with our video for today. So number 7, I have 2k to the third minus 5k squared minus 12k plus k to the third minus 8k squared plus 16k. Whew, those are biggies. So first, I'm going to start on the left. I have a k that I can take out. That leaves me with 2k squared minus 5k to the first minus 12. Then factoring the middle. Ooh, this is that fun factoring where there's a leading coefficient that's not 1. That means I need to multiply those two together and split the middle. I'm going to come over here off to the side and do that. 2 times negative 12 is negative 24. And in the bottom, I want a negative 5. My two numbers that give me negative 24 and a sum of negative 5 are negative 8 and positive 3. So then I would get rid of that negative 5k in the middle. 2k squared minus 8k plus 3k minus 12. Then take out a k from here. That leaves me with 2k. Oh, sorry, gosh, take out a 2 and a k. So that leaves me with k minus 4. Then in the second one, I can take out a 3. That leaves me with k with minus 4. So I've got 2k plus 3 and k minus 4. So here's the factors for the one on the left, for this guy right here. Here's factored form. K is the GCF. 2k plus 3 is one of them, and k minus 4 is the other. All right, whew, that was fun. All right, the one on the right, I can take out a k. Then I have k squared minus 8k plus 16. All right, much nicer. Leading coefficient of 1 makes my life a lot easier. So I just want a product of 16, sum of negative 8. That's going to be negative 4 and negative 4. So factor of k out front, k minus 4, k minus 4. All right, 3 factors here, 3 factors there. Here's the LCM. I know I need one factor of k because I have one factor of k in each list. I know I need a factor of 2k plus 3 because I've got one over here. Even though I don't have one on the right, I still have one on the left. So 2k plus 3. Then the k minus 4, I have 1 on the left, but I have 2 on the right. So I need k minus 4 and k minus 4. That's my LCM. Okay. Now I just want to make one thing kind of apparent. One other way that you might see this written is if we write that k minus 4 as a quantity squared, just so you're aware that that's how people like the ACT and the MCA, they might write it like that. It could be k and then 2k plus 3 and then k minus 4 quantity squared. So you don't need to write it like that, but if you want to, you may. I would not mark that wrong. All right, thanks for watching. We'll finish up these notes tomorrow. Have a great night.